Hello students, this video intends to help aid in your understanding of some introductory elements of experimental design as they are presented in the STAT 1040 and 1045 classes. Within this video, we will touch on objectives 1.1, 1.2, and 1.5 of Unit 1. We will be covering the concepts shown on screen. After some explanation, you will have a chance to practice these concepts at the end of the video. Let's get started. When approaching statistics, it is important to distinguish between the types of experiments and studies that are presented to you. The way in which a study is designed can convey whether it is reliable or not, as well as what type of conclusion, if any, can be taken away from their results. We'll begin by learning about the differences between an experimental study and an observational study. Experiments are done to test something specific, such as if a medication is effective or not. This is done by imposing some sort of treatment onto the subjects. As such, experiments are characterized by having at least two groups. One of these groups is the control group, and the other group is a treatment group. The difference between these two will be explored in a moment, but for now let's continue on with our definitions. A well-designed experiment involves the random assignment of subjects to these groups. If well-designed and corroborated, experiments can potentially display correlations as well as state a cause and effect. On the other hand, an observational study only observes its subjects and does not impose any kind of treatment. Think of these types of studies as nature documentaries. Researchers watch and observe without influencing outcomes. While they can potentially reveal relationships called associations between variables, they cannot say that one thing causes another thing to happen. Observational studies can further be designated as either cross-sectional or longitudinal, a concept which we will explore in a bit. First, let's get back to the control and treatment groups that we see within controlled experiments. The control group is the group being controlled for, meaning that they are not given whatever treatment the other group receives. Because of this, the control group is intended to be the baseline for comparison. On the other hand, the treatment group receives the treatment that is being tested. If we think back to a medication example, this would be the group that receives the new pill that is being developed. Through the experiment, this group is measured for their response to the treatment. These responses, or lack thereof, are then compared to our control group. Now it's time to discuss the differences between cross-sectional and longitudinal studies, both of which fall under the umbrella of being observational studies. The way I like to think about these two is that a cross-sectional study is like a picture, whereas a longitudinal study is like a movie. Cross-sectional studies only measure and collect data at specific moments in time, comparing different samples to each other. An example of a cross-sectional study would be if the heights of all entering USU freshmen were recorded throughout the years and then compared to each other. These data points would represent different individuals at different points in time, making this example cross-sectional. On the other hand, longitudinal studies follow the subjects over extended periods of time, comparing the same samples to themselves. An example of a longitudinal study would be if a group of 10 people were followed from adolescence until they were elders, to see if the different environments they lived in had an impact on their health outcomes. The observations gained from this would involve the same group of individuals over an extended period of time, making this longitudinal. We covered quite a bit of vocabulary, so let's do some practice to check our understanding. Problem number 1. A researcher is exploring the effects of elevation on athletic performance. In her study, she randomly selects 20 USU athletes to perform various athletic tests at a high point in elevation in Cache Canyon. She then also randomly selects 20 separate athletes to perform these same tests in a lab setting with a regulated atmospheric pressure. She measures the athletes' vitals immediately after these tests. Question 1. Would we consider this to be an experimental study or an observational study? Pause to answer and then press play to check your work. Answer. This would be considered an experiment, as we are randomly selecting and sorting the athletes into two groups. One of these groups is being measured for their response to the treatment, while the other group is being measured as a baseline for comparison. Remember, within our definition for a controlled experiment, it was stated that there needs to be a control group present as well as a group that has some sort of treatment imposed on them. Question 2. In this experiment, what is the treatment imposed in this study? Pause to answer and then press play to check your work. Answer. The treatment imposed would be the high elevation. To help us answer this question, we need to look at what is being questioned in the study. In the first sentence, we see that it is the effects of elevation on athletic performance that is to be tested. Therefore, the change in elevation is the variable that is being altered to see if there is a response. Problem number 2. The establishment of nuclear power plants have led researchers to wonder what impacts on health may arise over time. A group of 100 infants born within a close radius to a plant were followed over a 50-year period to see if growing up near the plant led to worse health as they aged. Researchers found that within these 100 subjects, 32 developed some sort of cancer over their lifetime. Question 1. Is this study experimental or observational? As a follow-up, is the study cross-sectional or longitudinal? Pause to answer and then press play to check your work. Answer. This is a longitudinal observational study. We can see that it is observational since there is no treatment being imposed and no control group. Rather, it is a group of people being observed without any researcher interference. Along those lines, this is a longitudinal study, since it is the same group of people being observed and the study extends over a long period. Question 2. Could we use the results of the study to say that by growing up near a nuclear power plant, you will have negative health effects? Pause to answer and then press play to check your work. Answer. No, we cannot say this. Since this is an observational study, we cannot assert causation. While we can say there's potentially an association between growing up near a power plant and poor health, we cannot say that one causes the other. Remember the golden rule of statistics. Correlation is not causation. If these or any other concepts require some more of your attention, feel free to watch this video again, reach out to your professor or recitation leader, or utilize the free tutoring services offered at the Aggie Math Learning Center. We hope this video was helpful, and remember that help is here if you need it.